Okay, let's get started. Um, well, good morning, good afternoon, or good evening, depending on your time zone. For me, it's still good morning. I'm in New York right now. I had some problems getting a nice visual for the background, and I'm here in some anonymous office, so I just made it a bit more fancy by putting my book in the shelves. By the way, I'm working on a second edition. One of the reasons I'm here to give some time for that, next to research and also WFM activities. But I'm glad to be able to share this some thoughts about AI with you. And as some of you already as you look at the visual, of course, generated by AI, AI is indeed the elephant in the room. Um, of course, we at CCmath, we're specialized in workforce management, but as some of you know, I'm also professor at the university, and both within CCmath and my activities as a researcher and teacher at the university do a lot of things with the AI. So I want to share some of the things. Some of these are more general, not directly related to WFM, and then we'll zoom a bit into WFM. Of course, time is limited; we cannot go into that many details. But I hope to give you at least, and I'm already talking about what we're going to do today. What I would like to do is give you indeed a non-technical understanding of AI. Of course. We're not mathematicians, some of you might be, but of course I do not assume that. So I'll try to give a non-technical understanding of artificial intelligence, discuss possible applications in contact center, and then of course zoom in WFM. But I think what's also interesting, and that's perhaps probably what's on your mind, is what are the consequences for me personally? What does it mean that indeed the world is changes? Will I be replaced by an AI? And that's of course an easy thing. I mean, will I replaced by an AI? Well, that sets a date, your retirement, because after that, that's not an issue anymore. But if you make a prediction, you should also always say when. So the question is, it's not the question if at some point we will be replaced by technology. I mean, technology is moving forward, so that will happen. But when will this happen? That is an interesting question. And I set up some polls. So I first would like, and I think that's interesting also for you to hear what others say. I'm very much interested what you think it's going to happen in the somewhat near future. So I'm launching this poll. Yeah, so it's live. So now in your screen you see a poll, and so the question is, AI is changing your world, and how will it change yours? Um, and I don't see any votes yet. Do you see what's here? Can you read it? Yeah, I see some votes coming in. Okay, great. So please take 1 minute to answer this question. So, what do you think will happen? And what are your ideas on that? Okay, I see about half of the people have voted. Just take a few more seconds, and then I'll show the results to everyone. You don't see anything. Okay, there's okay, yeah, perhaps, I mean, under activities, if you go to the bottom right, yeah, perhaps some of the other people I can see, but then the bottom right, there's activities, the triangle and the square, and then you click on that, and then you go to polls. Yeah, sorry about that. I hope everybody can see it now. You have indeed the chat icon. There's a small icon. You click on that, and then it says polls. Yeah, I was hoping it would. I'm of course at another screen. Got it. Okay, great. Okay, so then we'll take a few more seconds. So again, 4 options, and perhaps there's just choose the one which is closest to you. I mean, it would be great if you could also have some free field, but that's not an option into Google Meet polls. So in 5 years, there will be no more contact centers. In 5 years, WFM will be automated. I will have to dive into AI, otherwise I'll be obsolete, or it's just a hype. And I won't change them. Okay, great. I see now more votes coming in. Okay, I will publish, show everyone the results. So now you can see what others have voted. So most of you, actually, very few. Okay, that's interesting. Of course, I mean, and we're going to talk about that. You don't see it. I have clicked on show everyone the results. Wait a second. I do see it. Okay. Okay. Then it took a few seconds. Okay. So, but in case you don't see it, so most people, some people answered in 5 years WFM will be automated, but most people answered I will have to dive into AI, otherwise I'll be obsolete. And well, that's perhaps the bottom line of this webinar. So in that sense, and it must be a bit biased also, the fact that you're here must be because you're interested in AI. But I think that's indeed a very important point. Okay, let's move on. So well, I want to introduce you, tell you a bit what is AI, but as I said in non-technical terms. So this is perhaps a bit of a strange definition, but it's not next to reality. So you can, of course, many people describe AI as something that that requires human intelligence before had to do so. So computer like simulating, mimicking human intelligence. But actually, once the computer can do it, we do not find it actually that intelligent anymore. So some people also say our perception of AI is changing. Yes, as the computer can do things and we understand how in some logical, systematic way you can do something, you say, okay, that's perhaps not that intelligent. Yeah. But let's dive a bit deeper. Where does AI come from, and what are these techniques? Again, without going into the mathematical details. Of course, we all know what statistics are. And statistics, of course, there are lots of different areas within statistics. But for the sake of this talk and for this webinar and also for simplicity, let's take some big chunks of statistics. So perhaps you're familiar. If you had a course in statistics, you certainly are with hypothesis testing. Yeah, that's often used in, let's say, medical decision making. Is one medication better than the other? Then you take a sample, give one medication, another group of 100 patients, you give another medication. Of course, it might be random, that some people get better, some people don't. So therefore, you take relatively big groups. How big should these groups be? And then with a certain, you get things like p-values, etc. But if you had statistics, that definitely will ring a bell. That's hypothesis testing. Another area which is very well known within statistics is linear regression. Yeah? So that is explaining, predicting certain outcome on the basis of a number of features. Yeah. So given you can do that in medical science as well. Given certain feature, you have certain age and other and lots of other features of a person. What is the probability that a certain intervention will be successful? These type of things. But linear regression, you can also use it for forecasting. Yeah, also in call centers, and there it's used a lot. And actually, in our forecasting courses, it's one of the things we teach about. Okay, that's one area. And of course, the forecasting part is definitely very relevant to call centers. Then another area which is less known, but which is super successful in industry, which are all kinds of optimization problems. And there's one area, probably something, unless you went a bit deeper into that, but you might never have heard of. But one technique is called linear programming. And you are all in a way familiar with that, because if you do shift scheduling in a call center, then often there is some linear programming engine behind it doing that. Yes, and also in our courses on shift scheduling, we show how to do that in Excel. In Excel, actually, you have the Excel solver, and well, there are different technologies behind it, but one of them is linear programming, and you can use that to solve shift scheduling problems. Yes, and definitely, well, so that is but you can use that in many other applications. Yes. Now, over the last decades, a new field came into existence, and the statistics and optimization are really more mathematical fields, very applied, of course, but very mathematical. But over the last decades, this new field came into existence, artificial intelligence, and it has an overlap with statistics and with optimization. So linear regression, if you open an AI book, well, on certain aspects of AI, but the most popular part of AI, which is called machine learning. The first chapter, and now the 9 out of 10 books, it's about linear regression. Yes. There's also an overlap with optimization, and that is called reinforcement learning. I'm not going to talk about that, but reinforcement learning is used for things where you're in a certain situation, a certain state, and that changes over time. For example, you're playing check. When you're playing a check or any other game, you make a move, and then the situation on the board changes, so you have to evaluate positions on the board. Autonomous driving is the same. You're at a certain location, at a certain speed, and while you drive, of course, your location, your speed, direction, everything changes. So that's your state and how to react to the environment. That's basically what reinforcement learning does. Yes, but something that is perhaps the most the most successful new area, which really made AI really super popular over the last decade, is actually nonlinear regression. And now you see why I mentioned regression, because it is related to regression, but, and I'll explain that on one of the next slides, in a nonlinear fashion. And what you can do with that, you can do more precise predictions as long as you have lots of data. That's basically the bottom line. Yeah? And so you can do things with huge data sets at a high speed, as long as you have fast computer. Things like credit scoring. Yes, you have a loan application, and here in the US, there are well-known applications, and all kinds of people also getting angry about wrong uses of AI. I will not focus on that, but of course there are all kinds of ethical aspects about the use of it. But people getting loans denied on the basis of features that are, well, perhaps discriminatory. Yes, but that is one application. So predictions based on large data sets. And of course, generative AI. Yes, and a good example of that is, of course, the image, the elephant in the room, but also chatbots. And what have these three things, forecasting, credit scoring, in common is that you have a data set with, let's say, examples, with answers, and you use that to train some, to make some algorithm that later on can predict new instances on the basis of the attributes. Yes. So you have, and I'll give an example on the next slide. And all these three, you can say that is part of what they call supervised machine learning. Machine learning is the fact that the prediction is done by the computer, and the learning is basically, well, setting the parameters in the algorithm, and it's supervised because you first given a number of examples. Yes. And perhaps that sounds all a bit theoretical. So let's go to an example. Yes, let's do very simple, super simple linear regression. Already, we're here in statistics, so that's an old mathematical field. Well, not that old, but dating back a few hundred years. German scientist Gauss, a famous scientist, invented it in the early 19th century. Lots of things named after him. And what it does, you can predict with it. So let's have a look at it. This is an example. Here you have 5 employees of a firm. Yes, they have a certain number of experience. Some have a management position and some haven't. And as you can see, their yearly salaries are on the right. Yes, and we're in the US, and nicely high salaries in dollars. So my question to you is, so these are the examples that you give to the algorithm, and then it has to make predictions like this one. What would a manager with 10 years of experience earn? So it's supervised because for a number of cases you give the salaries. And now, well, it's about machine learning, and I'll give you the answer in a second. But now I ask you to do the human learning. And what is your prediction for a manager with 10 years of experience? And I'm launching the second poll. So the second poll is live now, so you can go again to polls. And my question to you is, what would a manager with 10 years of experience earn? Okay, I already see quite a number of votes. I'll make it public in a few seconds. Let's do it right now. Okay, so I made it. I published it. Okay, so let's discuss it. So in the answers, I see most votes to 95,000, which in a way makes sense. I see some people for a little more, and some people say not enough data to say with precision. Okay, so let's first have a closer look before we go into, well, determining what is the right answer, if there is a right answer. Yes. Okay, so in linear regression, so here we have, as they call it, in statistics, you would call it independent variables. But we nowadays, AI has all these nice terms. We call them features. So there are 2 features here, years of experience and whether or not you have a management position. Yes, and then you have the salary. And in linear regression, what you would typically do is you would look for a linear relation. And actually, in these numbers, there's a perfect linear relation. If you look for people not having a management position, then you see from the first data point, the person has 2 years of experience. Here, there's a person with 3 years of experience, and there's an increase in salary of 5,000. You go from 30 to 45. So apparently the decrease for 1 year more of experience, variable one, x1 here is 5,000. And if you then look at management position, okay, if you look here, somebody with 4 years of experience and compared to somebody with 5 years of experience, but with a management position, there's a jump of 20,000. Okay, 1 year of experience is 5,000. So the jump to a management position is apparently 15,000. Yes. So then you get this formula, and if you check it, it holds for all these 5 cases. So this is a perfect fit, this linear model. Hey, that's interesting. Okay, let's fill in 10 years of experience and one and the management position. Let's fill that in, and then you get to the 95,000. Okay, so that looks like a perfect fit. So I fully understand if you said 95,000. Yes, and and indeed here you see that a little bit of data, and of course this is a made-up example, so I made a perfect fit, but still. In linear regression, typically with a little bit of data, you can fit a nice linear model, and that works. Yes. However, I also understand some of you who said not enough data to say with precision, and also a couple of you who said 100,000. Why? I don't know what your thoughts were behind it. Perhaps you say, hey, this is model, and it's nice that there is this perfect fit, but how realistic is this model? Yes. Um, well, I mean, usually with salaries, after a number of years of increase, if you stay in the same position, usually the salary flattens. And perhaps for managerial positions, it takes the increase is a bit more before it flattens. Yeah. So perhaps the increase might be percentual, and then the increase for a management position, yeah, it's perhaps not 5,000 a year. Now you can say, okay, with these 2 data points, that fits perfectly the 5,000, but two data points is just very little. Yes, so both 100,000 and not enough data are, well, defendable answers. Yeah. So actually, what we would love to add is lots. If you have more data, then definitely this linear model would not fit. So then you would like to go both to a nonlinear model, and of course, the more data, the better our model gets. Yes. And what we would also like to have, we like to know more about these people. Perhaps there is some form of gender discrimination in the salaries. I would like to know the gender of the people, and perhaps the country where they're from, and perhaps previous experience, education level, you name it. Yes, then I can make a better model. And actually, all these things, that's what has been happening over the last years. Yes. Because what have we witnessed? We've seen a huge increase in the speed of computers. Yes. Why is that? Because things get smaller and smaller. Yes. It's amazing. I'm 60 years old. I started using my first computers when I was at university, when I was around 20 years old. I was working on the mainframe. Yes. And nowadays, this iPhone here has lots of more power than this PDP 11 I was working on at the time. So it's amazing how things have changed. Yes, of course, this miniaturization made computers faster, but it also increased the data capacity. Yes, and this is all due to Moore's law. Yes, if you're not familiar with it, it's interesting to look it up at Wikipedia. There's also where these screenshots come from. But the number of transistors that can be on a chip doubles around every 2 years. It will definitely stop at some time. It's a physical something we observe. No guarantee that it will continue, but it has continued for quite a long time. Yeah. Also, all computers are connected nowadays. The Internet of Things. Yes. And that all helps to make really fast computers. And what also helps, and not and which also helps making NVIDIA the most valuable company in the world, which is an amazing thing. They were in the area of GPUs, graphical processing units, just steering the screen. Yes, and that was just the thing for gamers who need their screen to react quickly to a move they make, because otherwise they're shot before they see what's happening. Yes, but nowadays, because there are multiple processing units on one graphical board or graphical card, you can do computations in parallel. Yeah, so actually the GPUs are used for parallel computations, which are used for these nonlinear models, to which I'll come in a second. So a couple of things: we saw fast computers, high storage capacity, and these computers even got faster, not just because of Moore's law, but also because of these GPUs. And we have data from lots of different sources. Yes. So we have the speed, we have the data, and we also have the algorithms. Yes, because only thanks to algorithms we can make knowledge of it. Well, and the knowledge, an algorithm, I guess you all know that, is just a step by step, a set of rules to come from indeed data to knowledge. And you can use algorithms for other things as well, but that's what we'll focus on today. Yeah. Of course, these algorithms, I mean, the old algorithm is linear regression. Yes. But we have so much more data, so we need to adapt these algorithms to the data size. Yes. Because with so much data, we can make way better predictions. Yes. And that requires more computing power, not just because there's more data, but also because these algorithms, for them to be more precise, you need different types of algorithms. And these algorithms are actually nonlinear regression models. And they come basically in two flavors. The first is decision trees. Yes. And that's actually a super simple idea. Yes. You have on the top, you have, you have like the starting node. And then every time you branch until you get to what we call a leaf, where there's no more branching, and then there's values. So simply apply to this problem. Yes. This model, how could such a tree look like? Okay, the first question is are you a manager? And do you have more than 5 years of experience? Well, if that's the case, then your salary is 80K. And if not, your salary is 70K, really based on the table here. You can just check it. Yes. If you're not a manager, then the right question to split, then there are three instances. There are three zeros here. Okay. So one leaf will hold one outcome and one leaf will hold two outcomes. Yes. So more than 3 years of experience. Yes. A zero here with more than 3 years. Oh, that's this fifth person is here, the 50K. And here it's the average of the two cases, the first and the third case. Yeah. Okay, so that's my prediction, and now I can predict, of course, the manager with 10 years of experience. Okay, so that is more manager, yes, more than 5 years of experience. So my prediction is 80K and not 95. Okay, I don't have yet enough data to really make a good decision tree. Yes, but if I have more data, that would be more precise. And so actually, there are all these prediction models, yes, that use groups of decision trees. Yes, and oops, that goes too fast. So instead of one decision tree, you have a lot of decision trees, which are trained actually on different subsets of data. And you sample your data, you get different subsets. And then you take, an average of the outcomes. And that magically, well, it's no magic, but interestingly, that works very well. Yes. And they call that random forest. Random because every tree here is based on a different, 80% of the data. And there are more algorithms like that. Of course, I don't have the time and to go into that. Then you really should follow a data science course. But super interesting how these algorithms work. And they are invented, let's say, 15, 20 years ago. Another one that you might have heard of is called deep learning. Yes. And why is it deep? Well, because it goes to multiple phases. And here you see um, how people typically, so this is your input. Yes. And the output layer can just be one node. Think of one node. Input is manager, yes, no, years of experience. Output is estimation of of the salary. And what do these nodes work? Well, actually, every node combines the input of the input layer. So here, 0, 1, yes, no, and a number, let's say 5. And then it does something very much like linear regression. And then it does some simple transformation on it. And then it sends the outcome to the new layer until you hit the output layer. Yes. And that is um, inspired by a neuron. A neuron in your brain has multiple inputs, and it only fires when the sum of these inputs, yes, gets above a certain level. Yes. Um, and so these things are called artificial neural networks. Yes. And there are lots of weights to train because just like in linear regression, on every arrow here, there's a weight. Yes. Like the 5,000 and the 15,000. Yes. There are weights on all these arrows. And you have to determine them. And these networks can be huge. Yes, so it's very hard to train them. Yes, or time consuming, and therefore we need these NVIDIA chips to do that. Yes, and because there are multiple layers, it's a deep network. Yes, so deep learning refers to the number of layers. When these were first invented, they were this size. Yes, and they already work perfectly. Yes, so if you have a few hundred of our call center employees, yes, the managers and the years of experience, then you can make a very precise model already when you do it like this. And then, of course, with one output node, only the salary. But yeah, I mean, ChatGPT is trained on a huge network uh, which is, which has actually, I think, 1 billion of arrows in this network. And so, and that's why it costs so much energy and time and computing power to solve it. Okay, so linear regression does this. You have some inputs and you take the sum of them, a weighted sum, and weighted with these numbers, and a nonlinear regression, this neural network does this, and with in every node some linear function. Yeah, so that's what's happening. So the key feature is a big difference. Of course, in the linear model, we understood what was happening. Okay, 1 year more of experience is $5,000 more. In such a deep learning network, it's a black box. Yes, you have all these weights and you see them, but it's very hard to interpret them. Yeah, but you just give all the input you had, and it just tells you what is most important, and it finds itself. Well, it doesn't tell you, but it finds what is most important, and also all kinds of combination. Yeah, and it takes a lot of computing power to train. Well, I think I've been clear on this. I want to also, in the interest of time, we have to move on, but just wrapping up. You have the old-fashioned statistical methods for prediction models, linear regression, the new models, nonlinear regression, old-fashioned, simple, fast. Of course, Gauss didn't have a computer when he did that, so you can also, small examples, you can do it on paper. These old-fashioned models, they work for small data sets. Yes. Modern models require lots of data. If you do not have lots of data, they look very good, but they're not precise on in predicting. We call this overfitting. So it's important that you have enough data. Yes, and these new methods are, if you have enough data, super accurate. They're hard to understand. The outputs are hard to understand. You have to believe it. Yes, so that's a black box. Okay, so that is like a summary of supervised machine learning. So that is really the thing until, let's say, 2 years ago. Yes, big thing that already changed a lot. Yeah, that for example, at the university, all our students, they go into this. That was really the hype until a few years ago. Still super relevant, but then people took the next step, and that generative AI. Now, all the people among us perhaps remember the time of the expert system. People will, in the 70s, people were saying, in 5 years, doctors are not necessary anymore. We'll have some big mainframe, a big computer that does it for you. And people were trying to put rules in this system. If you're coughing, okay, then you have a flu or a cold. Yes. And if also your temperature is more than 39 Celsius, then it is flu, these type of things. Yeah. I see something, Adam, there. Yeah, internally, they see patterns, these neural networks. But so, and sometimes, if you apply them to images, you might say, hey, this neuron represents a certain type of pattern. But it's hard to understand which pattern it recognizes. But you can also see it as pattern recognition. Yeah. Now, what happened a few years ago, that you can use this prediction to you not just to predict the salary, or if somebody will convert, or whatever you want to predict, usually numerical things, numbers, but you can also use it to predict text. So you give his input text, and then you give some new text, and then it tells you what, given it the training on the input, is a logical next word, and yet another next word. Yes. So that is what our current tools like ChatGPT do, and they are called large language models. Yes. And of course, nowadays there are lots of them, because the first that was really used a lot is ChatGPT. But then, of course, nowadays it's integrated. Microsoft has integrated it with Copilot. You can use Gemini in your Gmail, etc., etc. And it also works not just for text, also for images, for music, for there are lots of things you can generate with it. So then we call it generative AI. And generative AI is, well, basically a prediction model with some randomness applied to it. Yes, you give it a lot of images, and then you say, hey, make a new image, and then your input is like randomness to make it a little bit different. Yes, but it's based on all the earlier things it has seen. So let's first ask you a question. Is how often do you use Gen AI? So I just opened a new poll. How often do you use Gen AI? Okay, I'll share it. So now you can see. So most of you, okay, that's interesting. Most of you answered either weekly or daily. Yes. So I think that's good. But if it's really integrated in your work, in your email writing, if you can just push a button, okay, correct this email, I think you would be more in the every working hour modus. And nobody is yet in complete symbiosis with your AI tooling, which also interesting. Yeah, of course there are some disadvantages to generative AI. Yes, for example, by itself, it has no morals. It just looks at data it was trained on and then predicts the next data. Yes. So actually, there's a lot of engineering going on also in ChatGPT and there's actually some reinforcement learning going on and some human intervention to tell it. Of course, you can also prompt it. Hey, give an ethically good answer. You can tell it what you want it to do, and of course, in the background, you can also do that. Yeah. Large language models can hallucinate. They call it hallucination. I don't know if that's the right term, but it definitely can give wrong answers. Yeah. Why? There's no if you wanted to make like an addition, there's no logic of the computation behind it. Yeah. There are no explicit rules in it. It just looks at the data. So if it was trained on wrong data, yeah, it will give the wrong results. Yeah. But it can also do something else. And I'll give you a super simple example. I'm not saying it works this way, but it might give you some insight why it gives wrong. Suppose I'm training my large language model on these inputs, yes, which are all valid computation. Yeah, 3 times 2 is 6, which is correct. 3 plus 3 is 6, 2 plus 2 is 4. And now my algorithm, again, I'm not saying that ChatGPT works that, but just for the sake of simplicity, my algorithm says use the most frequently occurring words. Well, what will be the output? Let's look. 3 is the most occurring first word, plus is the second, 2 is the third, is 6. Yeah, so my algorithm will tell me 3 plus 2 is 6. Yes, because these are the most frequently occurring words, which is of course wrong. But my algorithm doesn't know it. It just looks at what occurs the most frequently. And something like this also happens in your large language model. Yeah, might happen. So it really gives wrong answers. And I think everybody who knows it often will know that it can really give the wrong answers. Yes. Also the internet is full of these simple examples of small computations where Gen AI really went wrong. So be careful with that. Okay, let's talk about the impact of LLMs. And by now there has been quite some research on that. Yeah. LLMs such as ChatGPT, they're really better at certain unstructured human tasks. Yeah, so writing marketing proposals, summarizing a text, writing an email, doing a LinkedIn posting, all these type of things. But it's not always the case. Yes, and I took this from a presentation that I saw recently at a conference. But people get better in general when they use AI. Yes. And what is interesting, actually, the people who are worst at a certain job, they get better the most. Of course, if you are bad in writing emails in English or just in writing emails, of course, then ChatGPT can help you really well. And while you already write fluently without grammatical or typing errors, yeah, there's little to correct. So typically, people who are not that good at a certain task, they profit the most from it. Yes. And there are certain tasks, these are tasks, the dotted line, which are equally difficult for humans, but AI is not the same. Yeah. So AI, certain tasks that are, at certain tasks, it's better than at other tasks. Yeah. So you have to be careful with that. Yeah. Okay. But, as we see, it automates like the simpler things better than the difficult things. And it helps you to be better at really complicated things. And so there is this nice book that has been really popular. So if you're not familiar with the book, it might be an interesting read for you. And so there's this Wharton professor at what is it, the University of Pennsylvania, who wrote this book about co-intelligence. So that is really a popular scientific, non-technical book. Yes. So, as it says, living and working with AI, and he has a number of rules which I think are super relevant. And given the fact that you think you should dive into it, I think it's not completely new, but I think it's good to have a look. So he says always use AI. Yes, try because it only makes it better. Of course, perhaps it's forbidden or you're not allowed to put certain data in ChatGPT. So, of course, think about your company guidelines, but always use AI. do it together. It's not AI replacing you, it's AI helping you. So it's really co-intelligence. Yeah. Prompting is a good thing. You should tell, okay, right now I'm in this situation. I want to do that. I want you to take this position. I want you to take to be formal or to be brief or whatever, and or even give a story before you start doing it. So treat it as a person. You don't have to say politely, please, but explain it things before you do. So that's prompting. So that's getting a thing by itself, how to prompt an AI. Yeah. And of course, if you dislike certain things, remember it's the worst AI you ever get. They only get better. Nobody knows how fast, but they will get better. So you better learn it right now. Yes. And one thing for you, it's easy to use to open ChatGPT to do something. To integrate it in the system is much harder. So for it to be used by, in order for an organization, it's hard to use Gen AI. For you as a private person, just do writing an email or writing a plan or doing a LinkedIn posting, it's really easy. Yes. So use it, and so that because, well, indeed, that's the way not to become obsolete. Yeah. Okay, let's move on to contact center. I realize I already used 45 minutes, but I mean, I needed to do this, and I think one of the main objects of this webinar is to talk in generalities about AI, and I hope some of these things were new and insightful to you. Um, well, main application, of course, in call centers is the use of Gen AI for chatbots. And of course, things are moving fast. Yeah. And this is, what Dell-E, well, you might see the word joke, it's DALI, but also this computer from a movie, his or her, I don't know, idea of a chatbot. So will this mean the end of contact centers? Yes, will mean there will no more contact centers. Well, given the answers you just gave in the poll, I think your answer to that is no. Of course, this is forecasting, and we all know long-term forecasting is very hard. It's also what Molek says in his book. He says, well, we don't know what the future is, if things will go really fast, or is this about the best large language model you get? And we really don't know. 2 years ago, we didn't even know about that. They didn't even exist. Or perhaps some people at companies like OpenAI were experimenting, but we didn't know of it. Yes. And of course, as a call center forecasting specialist, I can tell you long-term forecasts are often very wrong. And if you don't believe me, go to a website saying like the 5 or 10 worst tech forecasts of the century, and there are some big loss over there. Yeah. Current belief is, and that refers to what I just said, is that especially the easier tasks will be replaced by general AI. So count on less contacts, but longer average handling times, because the harder contacts, days will remain, and the simpler contacts will be optimized. Yeah. And again, and that's interesting, the least performing agents, of course, if an agent only does voice and not chat because he or she is bad in writing, yeah, chat, Gen AI can help. So it really can help, well, empower the least performing agent. So that's interesting. People get to the same level. So it's especially helpful in tasks you're less good at. Yeah, but the overall idea is that that contact centers will still be necessary, but then with a focus on the more difficult things. Yeah. WFM. Well, let's have a look at it. What are the WFM tasks that are around? Simply said, it's forecasting and then applying Erlang, safety staffing, and then making the schedules. Of course, there's much more to it, but these are the main activities. You can all involve some level of co-intelligence with them. Yeah, so actually, and if you look at them, forecasting and safety staffing are both prediction activities. Yes, forecasting is clear, you predict the volume, but safety staffing, you predict the service level, and then perhaps you change the number of agents until you find the right prediction. Yeah, so they all involve prediction. Yes. So forecasting is indeed so these and if you look at data scientists who do that, they will often apply the methods that I just learned. So if you are forecasting in Excel, but perhaps there's a data scientist who wants to try forecasting as well, they will use other tooling like computer programs such as Python. They will typically use one of these tree-based methods or perhaps some deep learning to do forecasting. And so you see that in more and more call centers and also in our software, we integrated some of these methods. Yes. What is super important and what is a bit the pitfall of data scientists moving into the area of contact centers is that in all applications of supervised machine learning, domain knowledge is crucial. Yes, these algorithms are available in tooling, but the main thing is how to apply it in a certain setting. What are the things that are crucial about call centers? Yeah, so experience about call centers, understand what drives call centers. It sounds perhaps a bit simple, but that is really of crucial importance. And that you see, go to LinkedIn when people talk about supervised machine learning, about application of AI. They say it's 20% AI, 80% understanding the business. So even if you're not specialized in AI, you will still be necessary. Yeah. Scheduling involves actually optimization. And optimization is partly outside of the range of AI, but there's also lots of advances in these type of algorithms. It's not just this deep learning where things are going on. It's not only Gen AI. Yeah, so in many other directions, there are also use advancements. I cannot go into details, but it definitely is also for scheduling. Yeah, and one of the things we are doing is we are actually sponsoring a PhD and actively trying also to get Gen AI working for forecasting. Yes, one of the things is, and that's about this co-intelligence, that it knows certain things that otherwise you have to put into the tooling. So it definitely can help you in that aspects. Yeah. So here are in a bit more detail these advances. This is my last slide before I'll get to the conclusion. And sorry for taking a bit more of your time. So you see that thanks to these better predictions using modern tooling, you see that the accuracy in your algorithm, both in your forecasting and safety solving algorithm, is improved. Yes, and of course that reduces under and overstaffing. It reduces bad service level. It reduces expensive real-time changes. Things can be done in less time. Yes, and of course, integrating AI in systems is not always easy. Yeah, but it changes the man-machine, the co-intelligence balance. So you get a higher quality in less time. That's the promise. Also in your manual work, and sometimes there is a manual part to scheduling, and there also you might be Gen AI might come to the rescue and help you doing things there. For example, Gen AI can also manipulate Excel sheets, and if you prompt it in the right way, you can do interesting things with that. This is what I already said, so that in forecasting, it can help make better, more precise algorithms, and it can help reduce the manual part in staffing. It can, it also can improve the accuracy. So moving away actually from Erlang or integrating it with prediction algorithms. That's one of the things we actively work on as well. And in scheduling, as I said, it can better algorithms reduce the manual parts, and Gen AI can help you reduce, the manual work that remains. Okay, let's conclude. And again, sorry for being for almost taking an hour. The overall conclusion is that jobs will remain, but content will change. Yeah. So if you're not doing it yet, and most of you have, almost everybody uses already Gen AI, I think it's really important to use it and emerge into it. It definitely is a hype, but I want to show you what's behind the hype, and I think the AI is there to stay, and already Gen AI, really, I use it every day, multiple times per day, so I think it's really super useful. Impressed by what it does, but there's more than just that around, and at CCmath we also actively integrate that. We have a team of young people who know about AI and also Gen AI. If you are looking into AI and thinking, hey, how can I improve my processes? So please challenge us. We are always ready for having a call and see what your challenges are, and see how we might be able to help you with our tooling or in some other way. Our next webinar will, by the way, be the official launch of the new version of our scheduling tool, which already has some great features in it, reducing. We're doing a pilot now with a customer where we significantly reduce the amount of manual work in the schedule. So I'm really excited about this new version. So please, if you're interested, contact us. So to conclude, if you're using algorithm and perhaps you're taking a data scientist from the outside who knows all about deep learning, your contact center knowledge, I guess most of you are contact center people, is really essential when you're using these algorithms. If you want to learn more, we also give training, so you can also contact us for that. As you know, I'm also a professor at a university here, just not related to CCmath, but if you're interested more and you're located in the neighborhood of Amsterdam, because it's on site, we have trainings about data science, so postgraduate trainings, data science, but also about Gen AI. So here I have a short link, have a look at that. And I'm very interested what you think of, what your thoughts are about this webinar. So I would like to post, and if you have to leave, I understand. We're late, so if you have to leave, I fully understand that. But if you have time to fill this in, this final poll, I'll be very happy. And in the same time, so there the answer is, the question is, did you learn something new? The answers range from old stuff. Okay, somebody says old stuff, one person. Yeah, sorry about that, but I see some more votes. I learned something new about AI, and I will dive deeper into it. So I'll publish it so you can see it before you leave. And if you have any questions, now is the time. Thank you very much for attending. And if you have any questions, let me know. Prompting is the power. Yes, it is definitely. Doc, yes.
I actually said that. I did that by accident, but really great presentation. Thanks, Ger.
Thank you very much, Doc. Bye-bye.